So OpenAI Assistant is a great tool if you know how to build things with it. So the API allows us to build and integrate AI assistants into our applications using the OpenAI large language models and tools. So companies tailor these assistants for a specific purpose and provide them with the relevant data for that particular use. Examples of these assistants include an AI weather assistant that gives weather-related information, or an AI travel assistant that answers travel-related queries. So these assistants are built with statefulness in mind. That is, they retain the previous conversations to a large extent, thus making the developers not worry about the state management and leaving it to the OpenAI. So the typical flow is something like this, that creating an assistant where we select the data to ingest, what model to use, instruction to the assistant, and what tools to use. Then we create a thread. A thread stores a user's messages and the LLM's replies. And this thread is responsible for managing the state of the assistant, and OpenAI takes care of it. And after creating the thread, we add messages to it. These are the messages that the user types to the AI assistant, or the assistant replies. Finally, we run the assistant on that thread. Based on the messages on the thread, the AI assistant calls the OpenAI large language models to provide a suitable response, and may also contact some tools in between, which we will discuss in a second. And if you go to their official documentation under the overview section, that's exactly how they're showing it. Step 1, create an assistant. An assistant represents an entity that can be configured to respond to users' messages using several parameters like model, instructions, and tools. And that's my assistant. So to create the assistant, you just run client.beta.assistants.create. And this client is coming from, it's a module of the OpenAI class here. And instruction, for example, this is an example instruction. You are a personal math tutor, write and run code to answer math questions. And for the tools, we are using type code interpreter. So this is one of the assistant type or tools here. In the model, you can definitely mention whatever you want. And then create a thread, just the thing that we discussed. A thread represents a conversation between a user and one or many assistants. It can create a thread when a user or your AI application starts a conversation with your assistant. And step 3 is add a message to the thread. And step 4, create a run. So that's very much simple, the 4 steps process of dealing with your assistants API. And if you go through this section, how assistants work, some of the key points you will find. I definitely suggest that you go through the entire document. You will learn quite a few things here in details. But some of the key points here is that assistants can access multiple tools in parallel, including OpenAI hosted tools like code interpreter and file search, as well as custom tools built by developers. And threads simplify AI application development by storing message history and automatically truncating it to fit the model's context length. And messages can contain text, images, or file attachments. The API supports image input for models with vision capabilities. I think this vision capability was just added today. That's what I got to learn from one of the tweets from OpenAI developers account. And the API provides control over image understanding through the detail parameter, allowing low or high fidelity processing. And runs represent the execution of an assistant on a thread. And run steps provides detailed information about the action taken by the assistant during the run. So here they explain the runs and run steps. When you have all the context you need from your user in the thread, you can run the thread with an assistant of your choice. By default, run will use the model and tools configuration specified in assistant object, but you can override most of these when creating the run for added flexibility. And this is a run lifecycle. Run objects can have multiple statuses, queued, required action, in progress, canceling. Queued means when runs are first created or when you complete the required action, they are moved to a queued status. They should almost immediately move to in progress. And in progress obviously means that the assistant uses a model and tools to perform steps. You can view progress being made by the runs by examining the run steps. Required action and required action. This is when using function calling tool, the run will move to a required action state. Once a model determines the names and arguments of the functions to be called, you must then run those functions and submit the outputs before the run proceeds. If the output are not provided before the expires at timestamps passes, roughly 10 minutes past creation, the run will move to an expired state. Okay, these are the various status of runs. All right, now let's quickly walk through a simple example where we want to accomplish a few things with an Assistant API. And the plan is here. First, we will integrate Assistant API using a retrieval tool to upload a couple of PDF documents and to use an assistant to query the contents of the document. Consider these as a mini retrieval augmented generation, that is a RAG application. Then use files object to upload the PDF files so that the assistant can access them, and create and employ the assistant threads and messages and run objects to query the uploaded PDF documents and coordinate all these concrete objects to interact and interplay together as part of these whole application. So the first cell in this Jupyter notebook is where I am creating a file objects as our knowledge base. So upload your PDFs in the retrievers database using a file object. The Assistant API breaks them into parts as chunks and saves them as indexes and vector embeddings. When you ask a question, retrievers find the best matches and help the assistant give you a detailed answer, just like a big RAG retriever. And actually, I just forgot to mention to define few of the variables here. So this client that was that I used, this is being defined right here. So of course, you need to have OpenAI API key to activate this. And one point here to remember that as a developer, I need not worry about the chunk sizes, vector databases, or overlapping chunks, all these internal techniques. All this is done for me seamlessly by the Assistant API. File tools object method clnt.files.create, this one, clnt.files.create, that's where it is all being taken care of. And the next is create an assistant object. So that's where I'm creating an assistant object, because to use an assistant and conduct task, first create an assistant object, supply the assistant with a model, instructional behavior, tools to use, and file IDs to employ for its knowledge base and parameters. And after that, that is after creating the assistant object, you need to create the thread. That's what I'm doing in the next cell. So here the thread is the object with which the OpenAI assistant runs will interact with by fetching messages from it and putting messages into it. Think of a thread as a stateful conversational session between an assistant and a user. Threads store messages and automatically handle truncation to fit content into a model's context window. And each instance of a thread object will have a unique ID with its respective added messages per thread ID. And the step 4 here, that is this cell right here. Here you add your messages to the thread for the assistant. So users interact with the assistants via thread messages. They add a message or content to the thread for the assistant to read and respond to it. So up until now, we have created relevant Assistant API objects, that is files, assistant, messages, threads as component object for our mini RAG application. And now I want to glue them all together by creating a runtime context for our assistant, where all these component objects come to play and interact. And that's what is being done in this cell, create assistant run. And you define your run, your thread ID, assistant ID, instruction, everything, instruction message. And finally, you execute this create assistant run method and get your run. So basically, a run is when you make the assistant act upon a thread's message. That is, the assistant uses its settings and messages on the thread to execute a task, like calling models and tools. During a run, the assistant adds responses as messages to the thread. And keep in mind that the assistant works asynchronously, meaning it has different stages such as expired, completed, failed, and cancelled. A run object traverses while the assistant executes the task through various stages, with the initial status as queued. And next, that is in this cell right here, what we do is loop through the assistant run until status is completed. So we initiate the run, kicking off asynchronously from its initial state of queued to its subsequent stages and statuses, looping until the status is completed. So we define a function here for looping, and our function loops until status is in one of the states we care about. And when completed, we can retrieve the final message returned by the assistant to our query or message. So in our case, it will be the question we posed to extract 10 takeaways from our documents. And coming back to the documentation, I just want to mention about this particular part that similar to Chat Completion API, the Assistant API supports function calling. Function calling allows you to describe functions to the Assistant API and have it intelligently return the functions that need to be called along with their arguments. Yeah, so you can read more about the function calling within the Assistant API right here. Also, file what's new. Let's quickly have a look at this. So in April 2024, we are announcing a variety of new features and improvements. So we are launching improved retrieval tool called File Search, which can ingest up to 10,000 files per assistant, which is 500x more than before. It is faster, supports parallel queries through multi-threaded searches, and features enhanced re-ranking and query rewriting. Alongside File Search, we are introducing vector store objects in the API. You can now control the maximum number of tokens. We have also added supports for the tool choice parameter, etc. And Assistant and Run objects now support popular model configuration parameters like temperature, response format, and top P. All right, so that is this particular area is really useful when building real-life applications.